So if you take a look up here, we have 3/4 plus 5/7. So do the denominators match? No, so I have to get the denominators to be the same value, and I don't know why I'm using the student pen. Oh, there's a student pen and then a teacher pen. They have different functions. All right. So what we're really looking for is, do you guys remember teachers talking about LCMs, least common multiples? Okay, so what we really have is we have a 4 and we have a 7, and we're trying to find the least common multiple between those two. So, like, what are the multiples of 4? 4? No, those are factors. I want multiples. So, like, what's 4 times 1? 4 times 2. 4 times 3. So those are the multiples of 4, right? So we've got 4, 8, 12, 16, 20, 24, 28, right? And I'm trying to find the smallest multiple of 4 and multiple of 7 that are the same. So what are the multiples of 7? 7, 14, 21, 28, right? So what's the smallest multiple between 4 and 7? 28. In this case, it happens to be 4 times 7 and 7 times 4, right? Now, if you're in doubt, you can always multiply the denominators together, but that usually gets things really big, right? With numbers, not that big of a deal because we can factor down pretty easily, right? And what you guys saw yesterday is that with rational expressions and we're dealing with like x squareds and all that, sometimes making things bigger get us into a situation that we can't necessarily get out of. So this is a technique that we sometimes use where we do the 4 times 7, right? We just multiply the bottoms together. We tend to do that only with numbers. All right, so what would I have to multiply with 4 to get 28, though? 7. So if I multiply the bottom by 7, I have to multiply top by 7, so I get 21. 7 times 4, which means I multiply the top by 4, and I get my 20, right? Everybody good so far? 21 plus 28 is, or wow, 21 plus 20 is 41 over 28. Right, and then simplify that if you... Everybody good with the basic process through there, though? So we're going to be doing the same thing, only with rational expressions, right? So if you take a look at the first one, what do you notice? Okay, why? Right, so is there any work that I really have to do? No, so I can just perform the indicated operation, right? So what is 7 plus 3? So I get 10 over 4x. Can that simplify? Yeah, to what? 5 over 2x. That can't go any further, so we're done, right? Okay, if you look at the next one, do the bottoms match? No, so if you don't know what to do, you can always just multiply the bottoms together, right? But we always want to ask ourselves, is there another way? Okay, when you have a monomial in each piece, right? You guys remember monomials from last year? That means it's one term, right? No plus or minus signs in the denominator. That's when we tend to do the multiplication of the two bottoms. All right, so this is where we're going to do the crisscross across and get 14 plus 9x cubed all over 18x squared. See if you can follow where those numbers came from. Right, so it went 7 times 2, x times 9x squared, 9x squared times 2. Right? All right, so to get common denominators, right, if you have a monomial in the bottom on each of your fractions, you can use the crisscross across to get the common denominator. So you go top left, the bottom right, top right, the bottom left, and then multiply across the bottoms. All right, so now is there anything we can group up on top? Is there anything that can combine up here? This is where you guys need to answer. No? Is there anything I can factor out? No. Now, we see a cube, right? So we might have the sum of cubes. Is 14 a perfect cube? No. So we don't have to worry about it. And then there's really nothing else we can do here. The only thing that you could do to simplify is break it up into its individual pieces. And as everybody remember, this is how we break out a fraction, right? Everybody good? And then if you simplify it, it's just going to get us right back to where we started. So we're going to wind up with 7 over 9x squared plus x over 2, which is exactly what we started with. So there's really no point, right? So this is going to be our most simple form. There's nothing else we can do to combine that. That's all we've got. Everybody all right with that? That one's a little weird. But everybody okay with the basic process, right? So when you have a monomial in the denominators, that's when you do the crisscross across. Okay? So let's take a look at something that we're actually going to use this on. This is more of a traditional style, right? This is the same problem from yesterday that I was messing up all over the place. Okay, so today I'm going to show you the other method and we won't be messing it up. So we always want to start off with factors, right? If you can get factors, you're in good shape. That's what we want. So x plus 2, can I factor that down at all? No. So it just comes along. What about negative 2x minus 1? Is there anything I can factor out of that? Negative 1. There's a 2x plus 1. And what happens to the double negative real quick? Becomes a what? Okay, so I can just actually kick that out right now. All right. 2x minus 2, is there anything I can factor out of that? A 2, so what am I left with? X minus 1, right? X squared minus 4x plus 3, can I factor that? Okay, so I get an x and an x. Two numbers are multiplied together to get 3, but add to get 4. The signs match are different. Match, and they're both negatives. Everybody okay? Yes? No? Maybe. All right, now, this is where it gets tricky. I have to figure out what is the common denominator between what I have on the left side and what I have on the right side. So what I'm looking for are pieces, right? If we go all the way back to here, right, we look for the least common multiple, which means I looked at the 4 on the left and I said I have to multiply that by some number and get something, right? And then I have to take the 7 on the right, multiply it by some other number, but get the same result. So I went 4 times 7 because those are factored, right? So if we come over here, I have a 2 as one piece, and I have an x minus 1 already on the left. Okay, what do I have on the right? X minus 3 and an x minus 1. So what is shared between the left side and the right side? What already exists on both pieces? Okay, so I know I'm going to have an x minus 1, right? So that's going to be one piece to my common denominator. I have it shared here and here. Okay? Now, every piece, every unique factor that I have has to show up in the denominator. So what do I have here that's not an x minus 1? A 2. So that means that I'm going to have a 2 in both of my denominators. Like that. Is everybody all right so far? So I have this piece and I have this piece, right? What is over here on the right that I don't have yet? I have an x minus 3, right? So now I have that under both. Do I already have the x minus 1? Do I need another x minus 1? No, because it was shared. I already have one. So this is what my common denominator is going to look like. All right, so we start off with whatever's shared between the bottoms, and then whatever unique pieces are there is what we add. Does that make sense to you guys, or no? I know this is a little piecemeal, but... Okay, because I'm taking this bottom, right, and I have to multiply something with it. So what's different between this denominator and this denominator? What's added? Yeah, the x minus 3, right? Okay, so I'm saying if I take 2 times x minus 1 and multiply by x minus 3, I get this thing. Correct? Okay, now if I come over here, can I multiply this by something and get this? What's missing from here, or sorry, what's different between here and there? The 2. So what I'm doing is I'm multiplying, like before we had 7 and I multiplied it with 4 to get 28, right? And then I had 4 and I multiplied it with 7 to get 28. Here I have 2 times x minus 1, and I'm going to multiply that by x minus 3, and I get this thing. And if I come over here and take x minus 3 times x minus 1 and multiply it by 2, I get the exact same thing. So I'm still getting a common denominator. It's just that I'm multiplying by an entire factor instead of just a number. But you want to have the same pieces on the bottom under both fractions. Okay, did that help or hurt for the explanation? Yeah, but is this making some sense, no sense? So the easiest way to do it is whatever's repeated under both bottoms, right? We have an x minus 1 and an x minus 1. That is considered a unique factor, right? It's its own thing. So it's going to definitely show up in both because it's already in both. Okay? We have a 2 here, so I have to make sure that I include it. And then I have an x minus 3, which is a unique factor, and I have to include it. You know, this is where it gets weird. Can I just multiply the bottom by something in a fraction and keep things equal? No, if I multiply the bottom by something, what do I have to do? Multiply the top. So what did I multiply this bottom by to get this line? X minus 3. So what do I have to add on top? X minus 3. No, because I'm going to wind up writing this as a single fraction. Okay? But if I cancel this out, I get right back to where I started, correct? So am I really changing anything? No. And that's really important. You have to make sure that if you wanted to, you could cancel and go right back to where you started. So that way you make sure that you're not changing values, you're just changing appearance. Okay, so what is in this denominator that's not in the original denominator on the right-hand side? The 2. So what do I have to add on top? A 2. And 2 times the 1 gets us back to 2. So is everybody okay so far? You think maybe with more practice we'll be all right? Because this, to be honest, this is the hardest part. After this, it's just like the last 2 sections we've done. It's just the really weird thing here is how do I figure out what to add to the bottom? Okay? And does everybody understand what I mean by a unique factor when I'm looking at the denominators here? Like if you look at both denominators, what are the chunks that I have, right? I have a 2, I have an x minus 1, I have an x minus 3. I already said x minus 1, so I don't care how many times it shows up. So I need to have those 3 pieces in my new denominator because that's what's in common. Okay? So I can write this as a single fraction now. X plus 2 times x minus 3 plus 2 times 2x plus 1 all over my common denominator of x minus 1 times 2 times x minus 3. So any questions on the basic structure, though, as to what I'm doing? I want to try to simplify this down. Can I simplify when I have a plus sign right in the middle of my numerator? No, I have to have just multiplication, right? So what I'm going to do is on the left side, I'm going to FOIL this out. Okay, I'm going to multiply this together. I'm going to simplify by grouping my like terms, and then I'm going to try to factor back so I'm just down to multiplication. So what that looks like is I'm going to FOIL here, right? So x times x is x squared, right? X times negative 3 is negative 3x plus 2x is a negative x. And 2 times negative 3 is negative 6. Everybody all right so far? Maybe. I don't know. Okay. And then we're going to distribute over here and get plus 4x plus 2 all over. And we're going to keep this denominator factored because there's no point in making it bigger because we want factored form. All right. So now do I have any parentheses on top? No, so I can start grouping up my like terms. Do I have any like terms? So I have just an x squared, right? Okay, so what's negative x plus 4x? Plus 3x. And then I have negative 6 plus 2, right? What's negative 6 plus 2? Negative 4. All over x minus 1 times 2 times x minus 3. So now I have it written down to where it's a single item, right? So what I have to ask myself now is, can I simplify this numerator? So can this numerator be factored? So can you think of 2 numbers that multiply together to get 4, but when you subtract them, you get 3? Okay, 4 and 1. So we know that the signs are going to be opposite because C is a negative, and we know that the bigger value is going to be a positive because B is positive. Okay, so now I'm back to just my regular old factors on top, factors on bottom, right? So now can anything cancel from top to bottom? X minus 1. So your final answer is going to be x plus 4 all over 2 times x minus 3. Again, the reason why we had to do all of this work is because this. If you have a plus or minus sign just in the middle of your work, you're in trouble. Okay, you have to do a lot of extra work to get rid of it. We can only cancel from top to bottom if we have only multiplication. So it means that I need everything in its own set of parentheses, right? Is this plus sign in any parentheses? No. So before I can factor, I have to somehow get rid of it. So what I do is I multiply out, get rid of all my parentheses, group my like terms, okay, factor, and then once I'm in factored form like this, I have the proper style. I have what I want. So now I can start canceling from top to bottom. So, you guys ready for something major, or do you want to try another one of the ones like we just did? How about this? We'll come back to part of this, but for right now, we'll just look at this bottom piece. Okay? Okay. So, do I have common denominators? No. So, I have to get common denominators, right? So, do I have monomials under each piece? No. I have an x plus 4, which is a binomial, right? And then I have an x, which is a monomial. So, I have to try to figure out here, what am I going to use as a new common denominator? Okay? So, is my left denominator factored? Yeah. Is my right denominator factored? Okay, so since though they're both factored, I know every unique factor I have under my bottoms are going to have to carry over, right? So what are the only two factors I have? X plus 4 and an x, right? And each of those are going to need to be in my denominator. So when you're getting common denominators, this is the way that you're going to look at it. Is my denominator on the left factored? Yes. Is my denominator on the right factored? Yes. Every unique factor type has to exist in my common denominator. So by that I mean if there was an x over here on the left, I only need one of them because it's its own factor. Right? Everybody okay with that? Yes? No? All right. So what did I add to the denominator here? What did I add? An x. So what do I have to multiply the top by? So I've got 1 times x. Okay? What did I add on the denominator, or to the denominator on the right? So I'm going to have that added to the top. All right? Again, everything just kind of transfers over as a single fraction. So that's what I need. Now that I have it as a single fraction, I can try to do my regular simplification stuff. Okay, so can I simplify with just a plus sign chilling in the middle of my statement? No. So how do I get rid of it? I get rid of my parentheses, group my like terms, and then try to factor back. So what's 1 times x? 2 times x plus 4. 2x plus 8 all over x plus 4 times x. Okay, so is there anything that I can group up on top? Okay, the x and the 2x, so I get a 3x plus 8 all over x plus 4 times x. Okay, is there anything that I can factor on top? 3x plus 8, can I factor that in any way? No. So is there anything that I can cancel from top to bottom? No, so I'm done. Okay, when you're solving these, you can't always factor back, but you have to check. All right, so you get rid of all of your parentheses on top, group your like terms, and then try to recreate new parentheses. So that way we can cancel from top to bottom. All right, everybody okay, you think, maybe? I don't know, possibly. Okay. So I'm going to actually steal this answer, because I'm going to need it for the other side here. All right. So if we go to the original problem, does everybody see that I have a fraction over a fraction? Yeah, everybody okay with that? So, right, I have a fraction divided by what's going to give me a fraction, right? So what that means is I'm going to wind up multiplying by the reciprocal of the denominator. But I have to get this denominator into a single fraction before I can use that rule. So 5 over x plus 4, right? Everybody should know by now we're not going to touch, right? And 1 over x plus 4 plus 2 over x, we just solved that. And that is going to be that. Is everybody good with that idea? Yes, or do I have to work all the work out? Everybody all right with where that's being stolen from? Right? So this is what my new denominator becomes. So now can everybody see that it's a fraction divided by a fraction? Right? So how do I divide fractions? Multiply by the reciprocal of the denominator, right? So I get 5 over x plus 4 times the reciprocal of this piece, which is x plus 4 times x all over 3x plus 8. Everybody all right so far? Yes, no, maybe? And this is just like what we did in the last section, right? I have multiplication of two fractions, so I'm just going to list out all of my factors. So I have a 5 on top, I have an x on top, I have an x plus 4, all over, I have an x plus 4, and I have a 3x plus 8, which you told me already cannot be canceled, or cannot be factored, right? So now, anything match from top to bottom? X plus 4s. So I get as a final answer 5x over 3x plus 8. And this is the simplified form of this big nasty thing. Alright? So you're going to only have like 2 or 3 of those, where it's a fraction over a fraction that has to get common denominators. Okay? Where you're going to spend most of your time today, and tomorrow, and maybe the day after, are problems like this, where you have a fraction plus a fraction that have rational expressions, and you have to find the common denominator within them. So these are actually from your homework. So I'm going to actually do some of your homework for you today. Unless you don't want me to. If you want, I'll save it for tomorrow, or do you want me to work it today? Okay. So, for number 5, what do you notice? The denominators, what? They're already the same, so do I have to do any work? No, I just do 9 minus 2x all over x plus 1, but I'm not done yet. I always have to check to see, can I factor something? So can that numerator be factored? 9 and 2, is there anything in common between those? So, numerator is already factored. What about the denominator? Is there anything I can do to factor x plus 1? No, so if both pieces are factored, that's it, right? There's no chance of me being able to cancel or reduce or anything. Right? Everybody good with that concept? All right. So now let's take a look at the bottom, or at number 19 here. Okay, number 19. Do we have the same denominators? No. So if you haven't figured it out, right, factoring is going to be major in this entire chapter, especially this section. So 12, I'm just going to keep for right now. And I've got my 3. X minus 3 is where I'm going to start because it's small. Okay? Can x minus 3 be factored? No. So it's just going to chill as is, right? Everybody okay with that? Okay, x squared minus 5x, or sorry, plus 5x minus 24. I need to know if that can be factored. So in order for it to be factored, because I have a lead coefficient of 1 on my x squared, I need 2 numbers that multiply together to get 24, but when you subtract them, you get 5. Do those numbers exist? What are the factors of 24? Give me the first 2 numbers that you can think of that multiply together to get 24. 8 and 3. Well, can you subtract those and get 5? Yeah. So you've got an 8 and a 3. Are the signs going to be the same or different? Different. And the bigger one is, so I have a plus and I have a minus. Everybody all right with that so far, you think? Yes? No? Maybe? Okay. So once we get into factored form, now we can start actually worrying about common denominators. So what are the factors I have under the right-hand fraction? or sorry, left-hand fraction. What are the factors? X plus 8, right? And x minus 3. So those are my unique factors so far, right? What are the factors under the right-hand fraction? X minus 3. Do I already have one of those? Yeah, so do I need to really add in another one? No. So what are all of the different factor types that I have? I have an x plus 8, right? And I have an x minus 3. So my common denominator is going to consist just of all of the unique factors. All right, so I have x plus 8, and you guys know what I mean by unique, right? What does it mean to be unique? There's only one of you, right? You're the originator, okay? So for us, x plus 8 is unique. X minus 3 is unique. Oh, I already have one of those. I don't care about anything after the original. Okay? So I have an x plus 8 and an x minus 3. That's going to be my common denominator. So now, if I compare the denominator on the left-hand side of this fraction and the denominator on the left hand of this fraction, what did I change to the denominator? Did I make any changes? No, the denominators are exactly the same, right? So do I have to change anything on the numerator? No. So the 12 just stays. Okay. What did I change on the denominator on the right? Okay, so if I add an x plus 8 to the bottom, what do I have to add on top? X plus 8. All right, so now I can write this as a single fraction of 12 plus 3 times x plus 8 all over x plus 8 times x minus 3. All right, so far, it's weird, it's a little holy snap, but are the basic steps, are we doing all right, you think, maybe, possibly? Okay, so now I have a plus here just floating, right? I don't have parentheses everywhere. So what that means is I have to get rid of parentheses, combine my like terms, and then check to see if I can factor. So get rid of parentheses on top. So that means I'm going to distribute the 3. The bottom I always want to keep factored. That's supposed to be an 8. Let's try that again. There we go. All right, can anything group up on top? Can I combine anything? Okay, the 12 and the 24, right? So what's 12 plus 24? 36, all over x plus 8. I said plus 8, thank you. And x minus 3. Anything I can factor out of the top between 3x and 36? 3. So if I pull out a 3, that leaves me with an x plus 12 all over x plus 8 times x minus 3. So now everything's back to being in factored form, right? You notice every single object is in its own set of parentheses, right? But can we cancel anything from top to bottom? So we did all that work just to go, okay, we're factored. It can't be simplified, but you have to always verify. Okay, and to verify, we get rid of all of our parentheses, we group our like terms, we factor again, and check to see if we can cancel from top to bottom. All right, so any gigantic pressing questions? Or do you guys just kind of feel like you don't know what to ask at this point in time because you're like, wow, that's a lot of stuff. Right? You're a little bit on sensory overload? Okay. So, I'll save this one for later. Here's your homework. Get it copied down. You've got 10 minutes to take some deep breaths, do your woosahs or realign your chi or whatever it is you need to do. So 7th hour, you're not like, wah! All right. Take a look at the homework tonight. Come in tomorrow with questions ready to go. Especially in the first set, 3 through 6, they're all they already have common denominators. Okay, so 3 through 6 should be pretty simple. 16 through 21 are going to be smaller factors, but they're still going to have different common denominators, different denominators. So you will have to find the common denominator. 27 through 30 are going to be kind of the bigger ones, and then 31 through 33, those are the ones where it's a fraction over plus or minus fractions in the denominator. Okay? So take a look at these, especially the 3 through 6 and the 16 through 21. You should be able to get a lot of those done, right? So if you have questions on those tomorrow, those will be a good place to start. Then I'll go through a couple, 27 through 30, and one more, 31 through 33, and then you'll get the rest of the hour to work. Okay, everybody clear with that? Yes, no?